Go over that unknown flow chart. This would be water solubility, right? Over here we said this would be soluble. And if the pH was greater than 7, basic, like an amine. And if the pH was less than 7, then this was acid. But what happened if it was not soluble? Insoluble. Then we want to check this in 10% NaOH. We get a split. Over here this will be the soluble side. And if it's soluble, it's an acid. Carboxylic. And then over here, we want to test it now in 10% HCl. Again, if we get soluble, then that's going to be amine. But if it's not, then we're going to do that 2,4-DNP test that we saw earlier. No precipitate, not what we want. But if we do get a precipitate, that means we're either getting aldehyde or ketone. Next thing we're going to do is the tolerance test. If we get that mirror, we know that it's the aldehyde, the RC double bond OH. If we don't get a mirror, then we need to do iodoform. And over here, if we get a precipitate, that means this is a methyl ketone. And if you get no precipitate, then we said this was what? Internal ketone. You should be able to go back in your notes and find the mechanisms for each and every one of those. This is going to go back to basically a carbonyl compound, in this case an aldehyde, and then the other half of it, which is over here, is going to be acidic. All I have left to do here is to go backwards here. Benzaldehyde could come from alcohol, aldehyde coming from primary ROH, and then this could actually come from a Grignard type reaction, and then we know that bromobenzene would come from benzene. This is going to be Br2, Fe, Br3. This is going to be the tough one right here. First thing, Mg, anhydrous ether, 2 H2CO, and 3 H3O plus. This one here, PCC, and then these two actually react together to give you a product. Don't forget to review the ones from lab as well. In fact, this one we'll do B first on this page. I'll do C on a separate page. So let's start with B. We have, what is this thing here? This is an oxime, and what that comes from, my benzene, CH2, C double bond O, CH3. Okay, so what do we have here? We have a ketone. So here's my ketone. The precursor to a ketone is what? Secondary ROH. This should come from an aldehyde. Aldehydes come from primary alcohols. We can see that this one comes from a 2-carbon extension from bromobenzene, halobenzene, and then that's going to go back to benzene. Let's fill in our reagents now. I put the Br on, Br2, Fe, Br3. Remember, it's a Grignard, so the first thing I do is I put in the Mg. Always has to be anhydrous ether. Then I'm going to use my 2-carbon extension there. And in 3, I'm going to put H3O plus. And here we have an oxidation from the alcohol to the aldehyde. We use PCC. Here we have another Grignard type reaction, and I'll just write in CH3, MgBr, followed by some H3O plus, and then again here this would be PCC, and in the last one here all you have to do is look at what's attached to the nitrogen and start it out with that. So I'm going to put HO, and then I attach it to NH2, benzene, CO2CH3, and a nitro group. Now notice the nitro group is in the para position, so one thing you want to keep in mind is that whatever we do here, we got to make sure that the nitro group is put on when we had what? An ortho para director. Now esters, this is a ester, esters come from what I said earlier. You want to make an acid derivative? You better make it from the acid chloride. And then the acid chloride would then come from the acid. In this case, we'll go back to benzoic acid. Now remember, I got to get this back to an orthopara director, so let's take this back to now toluene, which then now CH3 is an orthopara director, and this would go back to just toluene, which would come from benzene. Reagent time. Friedel-Crafts alkylation. CH3Cl, AlCl3, HNO3, H2SO4 to nitrate. You get a little bit of ortho M para and you separate. Over here it's an oxidation. 1 KMNO4, presence of OH minus, followed by H3O plus. Get H looking better. This we just learned today again. Remember, this was SOCl2, and then going this way, CH3OH.